is Staying Cool Lesson 2, Specific Heat Capacity. It is quite a difficult concept, so I need you to be careful and if need be, see this many times. I'm going to send you the PowerPoint and you can watch it and see it again and again later. So, specific heat capacity. Let's start by thinking a bit. When we are at the beach, why does the sand feel much hotter than the water when the sun is shining equally on them? Why does it take more time to heat a liter of water than a liter of oil? Alright, when we're walking on the sand is hot and then we go into the water and it's nice and fresh. How come they feel different? Alright, I hope you have some kind of answer in your heads. Now think about this. Do we all have the same appetite? Do we all eat the same amount of food? If you have a father and a son, does the father eat the same amount as the child? No. Everyone has his own appetite. We do not all eat the same amount. This is what you need to keep in mind when we learn about different specific heat capacities. The sand gets hot quickly because it does not need a lot of joules of energy to raise its temperature, and same goes for the oil. On the other hand, water has a huge specific heat capacity, so water needs a lot of joules of energy to raise its temperature. That is why things like electric kettles and electric water heaters waste a lot of energy because they are heating water, and water has a big appetite. It needs a lot of energy. So what is specific heat capacity exactly? Specific heat capacity is the heat energy needed, كمان بزون joules, to raise the temperature of 1 kilogram of substance by 1 degree Celsius. Mela biex insaħħan 1 kilo of material by 1 degree, kemm għandi bżonn joules ta' enerġija? Of course, the amount of heat energy you need depends on many things. I think you can come up with them even in your head. The mass in kilograms that you will be heating. If I'm heating 1 kilogram, I need a certain amount. If I'm heating 5 kilograms, I need a bigger amount. By how much you will heat it? This is called the change in temperature, and you're going to hear me saying a lot, delta theta, delta theta. When I say delta theta, I mean change in temperature. For example, the kettle will heat water from 20 degrees to 100 degrees. So the delta theta, or the change in temperature, will be 80 degrees. It also depends on the object's appetite for heat, which is the specific heat capacity. If I'm heating water, which has a big appetite, I'm going to have a big number. If I'm heating oil, which has a smaller appetite, I'm going to need a smaller number. So because of that, here comes the equation. So we're saying that the specific heat capacity is the amount of energy needed to raise the temperature of 1 kilogram of material by 1 degree. So Q is equal to M times C times delta theta, change in temperature. And if we had to make specific heat capacity subject of the formula, I will take M times delta theta on the other side and they become division. So C is Q all over M times delta theta. Where C is the specific heat capacity, Q is the heat energy, M is the mass, and delta theta is the change in temperature. The units of specific heat capacity comes from the equation. So if Q is measured in joules, M is measured in kilograms, and delta theta is measured in degrees Celsius, the units of C are joules per, because division, kilogram degree Celsius. This is a table showing different materials and their different specific heat capacities, so that you know that different materials have different specific heat capacities. There is no need to learn any of these values by heart. This table is just to show you different materials, that's all. So, if the specific heat of capacity of water is 4,200 joule per kilogram degrees Celsius, this means that to heat 1 kilogram of water by 1 degree, you need 4,200 joules. Oil has a specific heat capacity of 830. So to heat, sand. This has to be sand, not oil, because I couldn't find the specific heat capacity of oil because there are many oils. Alright, so to find the specific heat capacity of sand, which is 830, it means that to heat 1 kilogram of sand by 1 degree, you need 830 joules of energy. Much less than water, eh? Jiġifieri, that's why there is a difference between 830 to 4200. So that's why the sand heats up much quicker than the water. But then in the evening, it cools also much quicker. If you have a stroll on the sand at night, it feels cold, while the water in summer would still feel rather hot. Okay? So that is the explanation. Now, on your notes, find this page. It's the next page. Okay, so far we did the first two. And now we're going to fill in our notes. Okay, so we're saying that objects have different specific heat capacities to heat the temperature of 1 kilogram by 1 degree. Then read the notes well, because otherwise the video will be too long. The definition of specific heat capacity should be added to the important notes and definitions you have on the first page. So you write it 2 times, once here and once on the first page. You can stop the video at any time to write. Definitions and explanations. The equation. It is given in the exam. It's given as Q equals MC delta theta. If you need to find Cm or delta theta, you make the necessary arrangements. And then you have 3 questions. Question 1, to find Q. Question 2, to find C. And there is also question 3, which is a bit difficult to find the final temperature. This question 3 is for Track 3 students only. After this comes the experiment, but the experiment needs to be done in class.